You have quite a few articles, obviously. You're one of the leading experts talking about Healthspan, lifespan. And one of your papers, you basically say that the simple truth is that growing old is a thoroughly miserable experience for an unacceptably large proportion of the population. And then you go on to say that only 18% of people meet the scientific criteria for successful aging, which good health, function, and social engagement. So, Professor, why do only 18% of people age well? And then what does that mean for the other 82%?
Well, they're two very interesting questions, Jesse. I mean, the simplest one to answer is, what does it mean to age badly? Which is, I'm afraid, what 80% of us, for most of human history, have had to look forward to, although I sincerely hope that's changing as we speak. It means you've got chronic ill health, you're in a lot of pain, you can't conduct activities of daily living, so, you can't walk down to the shops and buy the newspaper easily. Your friends fall away from you. You're lonely. You're stuck in a house. Maybe that house isn't particularly warm in the winter or cool in the summer. So you're poor, miserable, old, lonely, and sick. Now, realistically, I don't see that as a positive outcome for anybody. Now, you may be able to keep your sense of humor, and you may be able to make the best of it, and this probably, none of this is probably your fault. It's just what happens. Now, on the other hand, let's look at somebody who is aging successfully. All right. They're largely free of disease or functional impairment. That means they can get out. That means they can stay employed if they want to stay employed. That means that they can volunteer if that's what floats their boat. They can see their friends. They can stay connected. So, a 58-year-old is like a 38-year-old, but just with less hair. So it's that kind of thing. And if they've got a decent job, they're doing pretty well. And so realistically, what happens is good health isn't, if you have good health, it doesn't mean that you're going to be blissfully happy, but it sure as hell helps. And that's, I think, where we come in.
Of that 18% that's aging well versus the 82% that's not, are those 18% doing things that other people aren't doing? Do they have strategies maybe subconsciously? Is it just luck? Is it genetics? What's the main difference that basically a fifth of people, older people, are doing versus the other 4/5?
Well, there's a number of things that you can do. So let's put it this way. Your life expectancy, how long you can expect to live, is a function of how healthy you are. That kind of makes sense. Sick things tend to die, healthy things tend to stick around. And you can add about 14 years to your life expectancy by doing 4 of 5 things that somebody who does none of them will have a much shorter lifespan. So, and those are: don't smoke, take sufficient exercise, watch your weight, drink moderately, and get an adequate intake of fruit and vegetables. We use a rule of thumb in the UK of 5 portions a day. And if you do 4 of those 5 things, you'll live about 14 years longer than somebody who does none of them. And that's the difference between having the life expectancy of the richest people in the UK compared to the life expectancy of the poorest people in the UK, approximately speaking. So yeah, there's a lot of positive things that an individual can do, but there's always been a limit to what an individual can do. What's interesting, I think, now is that we have, for the first time in human history, a sufficiently good grasp of the mechanisms that cause aging to be able to start to exploit those to develop new drugs and new interventions.
And one of the other papers you wrote, you basically say that aging is druggable. And you say essentially that although aging is complex, there is now ample evidence from multiple species to support the possibility that aging could be druggable, which would either result in compressing down the morbidity or extending the healthy lifespan. So, Professor, can we actually slow aging? Or is that still science fiction? Do we actually have the drugs that are capable of doing this right now?
Well, I think can I just ask you a question? Because I get this a lot, and it's genuinely interesting to me. What would slowing down aging look like to you? Because you have a picture in your mind.
My parents are retired half the year in Panama, the country. So when I go down there and visit them, I'm around a lot of, 60s, 70s, people in their 80s. And I would say, just being sharper, mentally, not having, whether early onset dementia, being a little bit more physically, having a little more cardiovascular, fitness.
Let me put words into your mouth. So, one way of putting it might be it takes you 80 years to reach 60.
Right.
Something along those.
Right.
If we're thinking about the average 60-year-old or the average 80-year-old, it's good because one does need to kind of tease this out. I think that the best way of looking at it's probably this. So you've obviously spotted these things yourself, by the age of 85 at the moment, nobody is in good health. The average 85-year-old citizen of the UK has between 4 and 6 distinctly diagnosable conditions. The lowest number was 1 in the survey that I'm thinking of, the Newcastle 85 Plus study, and the largest number was 15, and that's a pretty sickly person. And so obviously somebody who would be, who would have had their aging slowed at the age of 85 would have none of them. That would be one way, I think, of looking at it. That is kind of what you see in the animal models. And so where we first started to unlock the biology of aging, or at least a good place to start talking about it, was the observation from the 1980s onwards that single gene mutations in lower experimental animals, such as there's a little nematode called C. elegans that's used quite a lot, would live much longer, 75, 100% longer. And these animals live much longer because whatever you did to them made them much healthier. And so in that sense, their aging would be slowed. We can use a more formal argument within science about populations of organisms, where we would start to talk about altering the slope of the Gompertz curve, for example. But in a variety of animal models, these mutations delay the onset of pathologies, and because the animal is healthier, it lives longer. And you can imagine 2 different kinds of way in which that could work. I can delay the onset of all the illnesses, but not lengthen lifespan. So rather than in a human, living to be 85 and spending the last 15 years with illness, you live to 85 and spend the last 5 months with illness. That's kind of known as compression of morbidity. The other way of doing something rather similar might be we keep the 15 years of ill health constant, but we add 30, 40, 50 years of healthy lifespan over the top, extending lifespan. There are examples of both of those things happening in different animal models when you tweak fundamental aging processes. And so in that sense, in both of those, you could kind of say that the aging process is slowed, if that kind of helps.
How far away are we from actually having some drugs, kind of some futuristic drugs that can address this? It seems like in a lot of the literature that I was reading, they were talking about repurposing drugs, whether it be like metformin or was it like rapamycin or however you pronounce
rapamycin?
Yeah.
Yeah.
And
you have to, and again, there's a little bit of context that's kind of needed. The short answer is yes, we have the drugs now. is the simplest answer. When you're doing, so don't forget, the human race has very few drugs, maybe a couple of thousand. Okay, you have, and if you ever go to a pharmacist's, you'll see lots and lots of different formulations of stuff containing paracetamol or something like that. But we've only got a few thousand drugs, and the development of new drugs is both extremely expensive. It costs billions to develop a new drug, and quite slow. Getting a drug through clinical trials is a 15-year process. Why is it so expensive? Because 90% of candidate drugs fail. So you've got to kiss a lot of frogs before you find a prince. But with repurposed drugs, 60% of repurposing drug trials succeed. So if something is a drug and can be used for something else, that's really, really good. And the data where I would say, yeah, they're here, is I'm thinking very specifically of a trial done a couple of years ago by a lady called Joan Manick. And what she did was she took a cohort of older people, she gave them a low dose of rapamycin. Rapamycin is immunosuppressive at high doses, but at low doses, it extends healthy lifespan in lower animals. And so what she did was she gave these older people an 8-week low-dose treatment with rapamycin, and then she gave them a flu vaccination. Now, it's often forgotten that upwards of a third of our older people do not respond to vaccinations, because in order to respond to vaccinations, your immune system has to be working properly. So if your immune system is not working properly, a vaccine's no use. Now, what Joan got was people who couldn't previously responded after the rapamycin treatment. They were protected against multiple strains of flu. And if you followed all of those people through and asked them to keep diaries of how frequently they got coughs, colds, and other infections, the folk who had rapamycin got infections about half as frequently as the folks who got sugar pills. And so in a very real sense, those people's immune systems had been rejuvenated. And if you're not dying of an infection, you are going to live longer and you are healthier.
I heard you on a previous podcast when you were talking about the expense. You were saying that it was $100,000 per basically participant in a clinical trial. I mean, that's insane money. That has to be a barrier. And then what is kind of like the fallout of that? I mean, how many, or the implications of that? I mean, how many companies can afford to do that? How many countries can afford to do that? So then do you start seeing a divide between companies and countries that can afford to?
Well, I mean, this is not something that doing a full sort of phase 3 clinical trial is not something that any company would do lightly, or many companies have the resource for. So when people talk about, big pharma is big because costs are big. I mean, it also throws up something else about trials, which it's always useful to put in, which is an awful lot of that cost is participant protection, the paperwork. I mean, let's put it this way. One example was given to me by a colleague who actually runs these. Let's suppose I'm recruited to a clinical trial and, I don't know, I'm supposed to be flying into Puerto Rico to get my blood pressure measured. And I miss my flight in Miami. And I ring you up and say, I've missed my flight. Is there any chance you can pick up my hotel bills for the night? That, to give me a crummy $100 check for a motel, that has to have been cleared through formal medical ethics. And that clearance has to have been documented to show that you are not financially influencing me. And that is a tiny grain of sand in the massive project management of running trials. So Yeah, but what usually happens in a medicines development pipeline is that you'll have small companies that start up and they're maybe developing some candidate drugs, but their market is not the consumer. Their market is another pharma company. So you're hoping to be, a company will be hoping to be bought out by one of the big boys, and they will then in turn look at all of the pipeline and see where things go. It's drug development is a costly business.
Right. It's like in the tech sector where you are hoping that Google or Facebook or someone buys your startup and then you cash out and you're done.
It's that kind of there's no one man and his dog company sitting around developing this stuff. Or if anybody is doing things like that, they're kind of hoping that one of the big pharma companies picks it up.
Before we started recording this, you basically were saying about how, we're at the point now where these drugs are coming into existence. And so in the future, I'm not even sure, maybe not for us, but there will be a gap between like the countries or the people that can afford these drugs and the people that cannot. I mean, there's
always these. It's interesting. There's good news, there's bad news, and there's some aspects of what we might call the gerotherapeutics area that are no different from any other drugs. The only difference is that now we're kind of here. The good news is that we understand what at least some of the fundamental mechanisms of aging are. So I work on these things called senescent cells primarily. When they build up in my skin, they give me wrinkles. When they build up in my central nervous system, they give me cognitive impairment. They build up in my cardiovascular system, they give me cardiovascular disease. Build up in my bones, they give me osteoporosis. There's a huge amount of interest in either getting rid of these cells with drugs that selectively will kill them, that are called senolytics. My own lab has an interest in a niche area, which is reverting them back to normal. There's about 20 ongoing senolytic trials at the moment. An awful lot of this is done by a gentleman called Jim Kirkland, who was at the Mayo Clinic. He's now moved west, and he's really done more, I think, than most people to move this whole field along. And some senolytics are in early clinical trials, and they're showing positive results for some interesting diseases: idiopathic pulmonary fibrosis, diabetic kidney disease, those sorts of things. And so you can imagine a situation where you start to see maybe not rapamycin, but drugs in that class repurposed and used to enhance vaccination. You can maybe see a situation where senolytics are used. What then happens? And we actually know a reasonable amount about this because we can look at the past history of how drugs work or how drugs have been taken up. Rich people typically take up new drugs quicker than poor people. Okay, so access tends to, because they're able to pay for it. But the full public health impact of a drug can take decades to develop. Because don't forget, these drugs never stop working. I mean, an example, a case in point might be Ozempic. Okay, when Ozempic first comes out, there's a scramble for it. Now, if I remember correctly, I seem to recall that Novo Nordisk made as much, which is based in Denmark, at one point made as much off Ozempic as the GDP of Denmark.
Wow.
But, but the situation is not going to stay that way for long, because let's put it this way, this is the market operating. Where there is a demand, there will be a supply. And so if we owned that drug company, I'd have those plants running 24/7. And I would be looking to build more of them. And everybody who has a competitor drug is looking at us and saying, I want a piece of their market. And so as the demand produces that, the supply comes up, the price drops, more people access things. And and that's what I mean by the full impact on public health of a drug can take decades to develop. A case in point would be antihypertension medicines. Kind of the same story. And so you know, in that sense, when there's something new and exciting, the richer people always get it first. But they don't get it exclusively because the demand is huge. And what people tend to forget is that not accessing these drugs is not a cost-free option. Let me kind of give you an example that's close to my heart at the minute. A friend of mine is looking at nursing accommodation for his mum, which is a kind of thing we all have to go through. He's found a good place. You're looking at about £6,000 a month for nursing care, maybe for a couple of years, maybe longer. Over the next 20 years, ideally, but maybe 2-3 years, something like that. But that money's got to come from somewhere. Now, a drug, a gerotherapeutic, would keep you out of a nursing home. So at that point, let's imagine you're paying $6,000 a month, or £6,000 a month for nursing care, and $5,000 a month for the drug that keeps you out of a nursing home. You're still better off. And this sort of stuff is forgotten. And there is also a benefit to the economy because, if I'm in hospital or in a nursing home, I've still got a pension, let's say, but I'm not using it. Whereas if I'm healthy, I'm going to the bar, maybe I'm taking in a movie, I'm going for coffee, I'm traveling to see the grandkids, and I am an active contributor to the economy. So being healthy in later life is good for the individual, but it's also very good for the economy. And that's often forgotten.
In some of your papers, you're talking about the economics of aging. And basically, like in the U.S., around, I think, 18% of the U.S. population is 65 or older. By 2030, it's going to be over 20%. And, right now in the U.S., there's 10 or 11,000 baby boomers retiring every single day. And like in the U.S., of course, we have our social security system. Right now, we only have 2.7 workers paying in for every one beneficiary. And that's projected by 2035 to be 2.3 to 1. In order to be like kind of functionable, we have to have more like a 3 to 1. And then, of course, everyone knows that was it like the average person spends 90% of all their healthcare costs the last 6 months of their life. And so, when you have a state-funded healthcare program, obviously you do, the UK and the US for senior citizens, we have a Medicare, but basically, I guess the question is if you can create these drugs where, like you're saying, if you're 85 and then you're in really good health and then you just kind of pass away quietly, you're never really taxing the healthcare system. And then second,
you're actively contributing. And there is now, labor force planning is not my field, but I was privileged to have a chat to, he's actually from your side of the pond, a gentleman who works here, who's done some work on people's plans for their retirement. And rather sadly, the poorer citizens who estimate that they're going to have to work longer to have a decent retirement are the folks who most regularly are forced to withdraw from the labor pool, through ill health, through the kinds of problems we're talking about. Whereas me, I'll be honest, I have a pension, and there are days when I sit there and think, it's Monday. Is this the day I retire? It's that kind of, because as it gets closer and closer, you get closer and closer to that line from Friends of, I'd love to help you, but I don't want to. And that's fine because I'm basically in reasonably good health. I'm not sitting there thinking, oh God, I've got to drag myself in. My hip is killing me. How am I going to do another day on the building site? And so I actually think that the deployment of these categories of drugs as they come online is going to benefit our less fortunate citizens, I would hope, disproportionately. Because it's one thing to be able to retire when you want to, it's quite another to be forced out of the labour pool. And that's toughie.
And a lot of the papers that you're writing, you're looking to find kind of like one kind of cause of aging, where you're basically saying now, like, they're all attacking each individual illness or disease separately. Like, so, you got dementia, or you got diabetes, or you have, some type of cardiovascular issue or whatever, or osteoporosis. And you're basically like saying, like, a lot of the, or at least from my reading, is that, these are all kind of symptoms of the same illness, which is just aging. So if we can attack aging, we can then attack
if we go after the physiology of aging, then we can target multiple diseases and conditions simultaneously. Now, quite often, because this is the way that people tend to write it, research and intervention into the biology of aging is kind of almost positioned. You can walk away as though it's antagonistic or an either or. You either do disease-specific research or you do fundamental biology of aging research. Actually, the two are synergistic. You can argue about the balance of funding for them. Let me try and give you a case in point. Imagine there's a lot of superb research on the development of cancer vaccines, yeah? So trying to get the immune system to kill cancerous cells. Now imagine that I've got a tumor. I'm a candidate for a cancer vaccine, but I'm old and my immune system doesn't work. At that point, that medication is going to be ineffective for me. But let's imagine we did the Joan Manick rapamycin thing. 8 weeks, low dose rapamycin, and then I'm given the cancer vaccination. My immune system has been enhanced, and the medicine designed to target that specific pathology is more effective. And that, I think, is probably one direction in which the healthcare system might evolve. But we really do need to make a serious push on the underlying mechanisms of aging, getting the repurposing trials done, getting the drugs down. I mean, one important step that I would see in kind of telling us where we need to go is something called the TAME trial, which you may have come up against. This was produced, but this idea was first formulated or led on by a very talented man, Albert Einstein, in New York, a man called Nir Barzilai. And the question was, if you had a drug, to return to the way you kind of phrased it, you had a drug that slowed down aging, how would you know? An average drug trial is like 18 to 24 months. We're not all going to sit here for 50 years seeing who goes bald first. And so what Nir realized in discussions with colleagues was this, which is the time at which we develop our first age-related pathology or impairment. It's very variable from one person to another. But time from first pathology to second pathology is tight. It's like 18 to 24 months. So a drug that slowed down aging would lengthen the time from first pathology to second pathology. And the FDA likes that trial design. They approved the design. It's very different to the way that most drug trials are done, because rather than, say, recruiting 100 guys with migraines, splitting them into two groups, one group gets sugar pills, the other group get my wonder drug, and our sort of end point is, do I see a 50% reduction in migraines over 6 months in the guys who are taking the drug? TAME doesn't work like that. It takes a whole bunch of people, all of whom have a single starting pathology, maybe a touch cardiovascular disease, something like that. And half of those guys will get sugar pills and the other half will get metformin. And the end point is any first event to any first pathology to any second pathology. Why is metformin in the mix? Because it's known that diabetics on metformin have lower tumor instances than either diabetics who are on other drugs to control their blood sugar or the general population. And so it's in there very much as a stalking horse. And when that trial would conclude, and it is fiendishly expensive, so if you know anybody with a few $100 million knocking round in pocket change, please tell them to send it to the American Federation for Aging Research, which is based in New York. It's America's leading charitable body that funds the biology of aging. It funds a lot of young career scientists getting up there. And it's also hosting philanthropic efforts for the TAME trial. But what would happen if that trial rolls forward is it would probably be deblinded, because some of the guys getting metformin would have benefit. And then metformin would become the comparison for any new gerotherapeutic drug. And underlying that study is a lot of complexity where people would be looking in and saying, okay, which cluster of first events went to which cluster of second events? And that would tell you a great deal that would allow you to personalize kind of treatment strategies, I think. That's probably what the future is going to look like.
Do you think these illnesses are reversible in people that are, like, say, in their late 60s or early 70s? To me, it seems like if you have 30 years of bad diet or whatever, bad habits, bad lifestyle habits, and these diseases kind of just like every year just getting a little bit worse, so that the time that you have the symptoms, it's already like 30 years too late? Or can you reduce 30 years of bad lifestyle and just bad choices and like take some, a few pills, and 6 months later...
Don't let them fob me off with lifestyle choices. I want pills. But
right.
Yeah, I mean, there is some evidence. I think it's an open question. And it would be a big speech to say you can get back 100% of the changes in any conditions. It would be an equally big speech to say you can't get back anything from any condition. So there's an element of nuance in there. We know from senescent cell deletion studies in mice, and these fascinate me. This was very clever work from Van Droosen, Darren Baker, Jim Kirkland, and others, where you can make transgenic mice in which it's possible to delete their senescent cells because you've engineered in a gene that will kill that particular cell. Okay, but the gene will only be expressed when the cell becomes senescent, and killing will only be triggered when you add something to the animal's drinking water. The system I actually like best is one I saw in Japan, where senescent cells express the receptor for diphtheria toxin in these mice. Mice don't get diphtheria normally because they don't have the receptor for the toxin. And so what you can do, therefore, is you can just put diphtheria toxin in the mouse's drinking water, and any senescent cell is killed. And you can do two kinds of experiments with these sorts of mice. You can remove senescent cells all the way through the animal's life, see what happens. You can let the animal fill up with senescent cells, then put the magic juice in the water and see what happens next. And what you see in the mice is you get a surprising amount of function back. And the data that I like most, because I quite like simple outputs, there's loads and loads of data, but I like wheel running, voluntary wheel running. And old mice that have had their senescent cells removed run about twice as far and about twice as fast as their litter mates, their siblings, who haven't had their senescent cells removed. And the key thing about this is nobody's making the mice run. They're running more because they feel better. And if you ever own a pet mouse or a hamster or something like that, one bit of public engagement of science I like doing is when that animal is on a wheel, it's genuinely enjoying life. There's an interesting paper from the Royal Society where scientists just got mouse wheels from pet shops, put them out in the wild and set up camera traps. And wild mice will take time off from looking for food to run on the wheel. And so these guys are genuinely having a good quality of life, which is kind of what we want. So you can get a chunk of stuff back. There is, but not all of it. And I can think of reasons why you wouldn't. And in the case of, for example, I think in the human population, to sound a more negative note, with high levels of obesity for a long period of time, if you manage to diet back, there are traces left of the health conditions beforehand. But that have it, so, you could summarize it as, how do I get out of a hole? Well, the best way to get out of a hole is not to fall in it in the first place. But climbing out the hole is a hell of a lot better than staying down here all day.
How much does the social interaction and things like that factor into this? There's a famous Harvard study that started in 1938 and it's been ongoing. Was it like going for over 80 years? And they were looking to study what makes people live longer, stay healthier, be happier. And they find that basically the number of close connections is the strongest predictor of a long life and a happy life. And that loneliness is as harmful as smoking or alcohol abuse. I mean, and like when you read like the blue zones, the regions where people live to be 100 plus, it seems like they'll have a sense of purpose. They have, a lot of friends that are still valued in the community, things like that. I mean, how much is this is mental? I guess is the question.
You've always got to be. It's a fascinating area, and it's one that one should always be very careful of the sweeping statement. All right. Now, there is an interesting, some social scientists will know what I'm talking about. There's something known as the Hawthorne effect, which I think illustrates this quite well. So, as I said to you, a lot of older people who are in poor health are lonely. And so what may happen is you suddenly find that you've been picked up for a trial and somebody installs a box in your kitchen and comes to talk to you twice a week about how the box is going. Your health will improve. You will feel, and your positive feelings of well-being will improve. The box can be a cardboard box with twinkly lights on it. It's not the box that's doing it. It's the fact that there's somebody who finally cares whether you live or die, is having a chat to you about something and you feel engaged. That's the Hawthorne effect. The other thing is that one of the biggest mistakes that you can make in any intervention, whether it's diet or exercise, is to assume that everybody's psychology is the same. Oddly enough, this was brought home to me for reasons that don't matter. I was on a survival course in Guyana, where we trained together. And then we would spend a week alone. Each of us would be alone for up to a week. And when I came back, don't get me wrong, I was glad to see the guys I was with. They were a pretty fun bunch of people. Quite a number of them said they got really lonely. Me, I just found it was great. I could wander around and talk to myself without people thinking I was a loony. So I no longer had to mutter in the corridor to concentrate. I could walk around Guyana screaming. And people have very different responses to loneliness. And the more you dig into the research, it picks it up. It doesn't mean that you can, you're lonely. If you feel lonely and miserable, then you are lonely and miserable. But it's possible to be isolated and not that bothered. You have to be a little bit careful about this. With the other things like diet, social connections, these kind of things, you have to be really, really careful in the absence of randomized control trials with things like, and there's an awful lot of, sticking with the blue zones things, I had to do some discussions around centenarians a while back. And you'll often see it, centenarians are hailed as, isn't it wonderful? These people are living a long time because they eat a traditional Mediterranean diet. And I've had to sit people down and say, look, that's because they're old and they live in Greece. What will you expect? And in the end, I dug up health tips from Irish centenarians who recommend a traditional Irish diet of Guinness and Irish stew. Yet strangely, no one's punting that as a diet solution because it doesn't fit the vibe. And you have to be really careful about disentangling cause and effect. And an interesting one where you see this in the diet field is something called reverse causation, but it's common quite a lot. So the best example of showing how reverse causation can kind of deceive you is from a study called the Scottish Mental Survey 1936. So what happened in the 30s was, for reasons that no longer matter, all Scottish 11-year-olds were given an IQ test. Those results were filed and kind of forgotten about. They were rediscovered in the 1980s along with the test book, and the results are non-anonymized. So you had, say, my score at age 11, and then you could go back and give me the same IQ test that I'd sat at age 11. And you could get my score on an IQ test that I couldn't remember doing. And so this is very useful for a variety of things. But where I think it did some of the most interesting work is in this reverse causation area. So there's a very, very high correlation between high cognitive functioning and the intake of fish oil. So you could sit there and think, okay, the fish oil is good for you. If you look within the people in the Scottish Mental Survey, there's no correlation at all. It does nothing. So it's not the case that fish oil makes you smart. Smart people tend to be quite health aware. And so these older folk will be sitting in the dentist's, as we all are, reading some faded magazine. They've come across an article from a journalist that says fish oil maintains your brain health in later life, and they all start taking it. And this kind of reverse causation effect can mess around with a lot of things. And the solution to these kinds of reverse causation effects are randomized control trials. But as we've said before, randomized control trials are expensive. A pet bugbear of mine, I will be honest, is that governments seem to place an awful lot of emphasis on promoting healthy eating behaviors. I wish they would place the same emphasis on funding the randomized control trials for diets that would show you what healthy really was. That, I think, would be really, really helpful. And case in point that kind of entertains me, it's one paper that shows how you can get things wrong. Concerns, there's been this sudden, I think it may be dying away. There was a sudden uptick of concern about ultra-processed food. Now, beans on toast is an ultra-processed food, but it's also a pretty good source of diet of protein and fiber if you haven't got much money. So not all ultra-processed food is bad. But there's an interesting paper that shows that consumption of ultra-processed food is associated with a lot of poor health outcomes. But it's also associated with an elevated death rate from road traffic accidents. It's very difficult to see how beans on toast makes you likely to be run over by a car. So what's going on? And what, of course, is going on is if you think about the kind of person who on average might be consuming a disproportionate amount of ultra-processed food, maybe they've got other problems going on in their lives. Maybe they've got mental health issues. Maybe they're on the margins of society. Maybe, they're a complete mess and they step off the curb at the wrong time and it's adios muchacho. Now, it wasn't the beans on toast that killed them. It was the consumption of foods of that type was disproportionately frequent in people who are that unfortunate. And you've got to kind of unpick stuff like that, particularly if you're going to bang the table in the way that some people who are keen on diet seem to, and say, this is what you've got to do.
What are the actionable things that people can take away from this?
Actionable things, get the basic stuff right. Okay. It's one of those, I make no bones about this. There's an old thing, there's an old nostrum in ethics, which is that ethical standards are what we can, of behavior, are what we can reasonably expect from one another. All right. If you set an unreasonable standard for everybody, then it's just for the birds. And I'm also not adverse to the argument that not eating bacon sandwiches your home life is not a good trade-off if what you get is an extra 18 months in a care home. Okay, so I think there's what you can reasonably expect to do. I'd quit smoking. I really would. I fail to see an upside, but if not, do be aware that that's one of the most risky things you can do. So if you're ever frightened to say going skydiving, don't worry, mate. Your risk is that high. You may as well throw yourself out the plane. Okay, quit that. Try and watch your weight. All right, watching your weight is tough. I should be very curious about what the effects of things like Ozempic are, because dietitians see two classes of problem person. People who are overweight, you want the weight to go off. People who are underweight, you want it to go back on. About 90% of those diets fail in 18 months because appetite's very tightly programmed. Drugs that affect appetite, like Ozempic, could be a game changer for that, because then you can be the weight you want to be. And the weight you should want to be is, relatively well muscled for your size. Try and work around that. Try and get exercise. Well, how much exercise should I take? What kind of exercise should it be? Whatever you can fit into your schedule is what you should be doing. If you can only afford to go for a walk, go for a walk. It's that kind of, it's kind of a little bit like asking, there's guys shooting at me, what kind of cover should I get into? Whatever cover is available, because it's a damn sight better than standing out there waving at the guy. Yeah? So at diet, exercise, try and eat your fruit and vegetables. You do those sorts of things, you've built a very good foundation going forward. Moderate alcohol consumption. All right. Not zero, but not, if you're having it on your cornflakes, it's a time to sit back and have a friend tell you need to reconsider your life choices. You do those, that's 14 years differential life expectancy right there. Then you start to worry about other bits and pieces that might float your boat. Whenever people ask me about, weird and wonderful supplements, I always apply what I call the gym membership test. If it costs about the same as a gym membership per month, you should see if you get the kind of benefits that you would get from a gym membership. If it's less than that, get the gym membership instead. It's that those kinds of areas. Monitoring your blood pressure. Hypertension's an important one. For a lot of people, it's silent. For a lot of people, it isn't. But do get your blood pressure checked. Standard other bits and pieces along those lines, you're probably doing quite well. Beyond that, it's very much, at least for me, a matter of personal inclination. And what I would always turn around and say, because if people are interested in shows like this, they're probably a little bit curious. What I say doesn't matter really. Why I say it matters a great deal. And I would say do what you've done, Jesse. Go to the primary data. You know, you'll put your own spin on that. And people will be happy to discuss that with you, because in theory, at least in this job, the only discussions between us are about the interpretation of data. And one of the things that, at least also in this job, is important is if you're the kind of guy that can't change his or her mind, then you're the kind of person the scientific community doesn't need. You know, changing your mind is a strength in this job, not a weakness. And the best way to make sure you don't fall into a trap of your own making is bouncing ideas around with other guys. You know, you do those sorts of things, you'll also tick the curiosity box, which doesn't kill you.
What do you think about older people being on like a preventative statin? It seems like that's a pretty common thing that I've noticed.
Depends on who it is. Yeah. I mean, I'm with the statins. There's a very famous trial in the States where effectively they asked for one of the insurance companies asked one of the prominent medical schools to take a look at folks on their books, and just to answer the question, who is the most likely person on our books to have a myocardial infarct, have a heart attack? And the answer came back, somebody who's already had one. And so what that company did was it did a two-arm trial. One group of patients got the best available treatment, which was physiotherapy, and the other group got best available treatment, which was physiotherapy and statins. 25% reduction in secondary myocardial infarct in the group with the statins. And what made the choice of what happened next interesting was this company controlled all aspects of the healthcare pipeline. So if you bought their insurance, you could only see their doctors at their hospitals. Quaternary and intensive care is pretty expensive. Primary care is really cheap. So if you control the whole budget and you can save money on quaternary care, you can plow that into primary care. And so the results from that study indicated it was cost effective for the company to start recommending statins to people higher up the chain. And it's good for the people because you're then potentially seeing reductions. You do need to trade off on statins with genetic background effects for people. So if you are a low body weight female with a lot of muscle mass who's been recommended statins, I would move into that quite carefully. I would definitely have a serious conversation with my doctor about that, knowing that there's some risks of muscle damage. So, so in that sense, the mistake to make is that everybody is genetically the same. And at that point, I think, taking a close look at what genetic background effects you know about. I mean, realistically, I carry a genetic disease allele for hypertension. So, should I be having medication to control my blood pressure? Hell yes. Should a guy who's normotensive and has no genetic background risk be taking it? No. And a lot of this stuff is just common sense, but somehow or other common sense seems to go out the window sometimes when we're chatting about these things.
Yeah, I was asking because my mom was put on she's put on a statin, and one of her other female friends as well, and they both had like neck pain and like weird like tingling sensations, and they both
it's one of those things. I'm actually quite keen on it, which is this is why it's better not to medicate people early on. We have work, there is no drug without a side effect. And what you're doing, I think, whenever you're prescribing a drug is you are making the calculation that the benefits outweigh the downside. That's now, sometimes that'll be a no-brainer. Oh, I don't know. I've got an infected wound in my leg. I need antibiotics. So long as I'm not actually allergic to them and won't die of anaphylactic shock, then that's a no-brainer. Give the guy antibiotics. With other bits and pieces, particularly if you're taking it for a long time, it's what's the risk-benefit calculus. And this is one of those where I'm always of the mind that nobody is more invested in your own health than you are. And at that point, you've kind of got to take control of it. And interestingly, I think that there is some basis in the literature that guys who do that actually do better. For two reasons. One, you feel you're in control of your own life. And the other one is, if you've spent some time getting up on how you think things work, what your treatment options are, and you've kept an open mind, then you're actually pretty engaged.
Reading kind of some of the literature, it seemed like one of the issues, at least with researching it and getting research grants and whatnot, is the fact that they look at a lot of these illnesses with aging and aging as itself as natural. And then you have other people or other experts that don't really look at it as natural, and that it's just like, and then also like, is diabetes and again, dementia and Parkinson's, etc. Like if you're looking at it as one individual illness versus like this is all one branch of aging, it just looked like the way that like the terminology and the classification, and if you're saying it's natural or if it's not, or it really changes on how you can actually study it. Like some people don't look at it as that important because like, oh, it's just everyone's inevitably going to get sick because they're old. Like it's not. So how you actually, I mean, I'm not sure if that makes sense, but it's kind of
no, it makes perfect sense. Yeah. Don't forget, we have been here before through the 20th century. If you went back to about 1890, people would have seen cancer as natural because it's just something older people get. Now, if I label something as a disease, that actually has two concepts that kind of carry with the label. The first one is I think it's bad. And the second one is I should do something about it. Okay. And I use the example occasionally because it's a high salience and polarizing issue. Imagine I turned around and said, immigration is a disease. You've picked up I think immigration is bad, and I'm sure as hell going to do something about it. Whereas if I turn around and say immigration is a natural process, that suggests I think it's at least neutral and possibly benign. And the sense of urgency of doing stuff about it is diminished. So in that sense, disease is not disease is what we choose to label a disease as. People had cancer when cancer was considered to be a natural process. People had cardiovascular disease. In fact, the early history of the Cancer Research Campaign in the UK, one of the biggest problems that they felt they would have, this is in the 1920s, 1930s, with fundraising, was that people would not give money for cancer research because they thought that cancer was just a natural process. And so in their early stages, they focused on childhood cancer because the one thing everybody could agree on is a kid is not an old person. And therefore cancer is not a natural part of getting old. And therefore cancer is a disease, is the logic. But the overwhelming majority of cancers are in older people. And this argument all grew out of basically ignorance about how aging works. Only in about the last 30 years have we had really good handles on what the mechanism of aging is. And senescent cells is this nice case in point. As I said earlier on in the podcast, when they build up in my cardiovascular system, they give me cardiovascular disease. We call that a disease. When they give that, they build up in my brain, they give me cognitive impairment, and we call that a disease, Alzheimer's. When they build up in my skin, they give me wrinkles, and we call that a natural change. This is about as logically consistent as saying, when I pour coffee out of the coffee pot, it's coffee. But when I pour coffee out of a teapot, it's tea. It makes no sense at all. And now that we've got mechanisms, hopefully we can address these kinds of underlying conceptual issues. They are a bar quite often. I've never personally understood. One of the great things about the fun things in being in aging is you get asked questions that I would never get asked if I worked in oncology. Now, I'm sure nobody wanders up to a consultant oncologist and says, "Why are you giving that guy radiotherapy? He's just going to die anyway." You know, why are you treating that guy's diabetes? He's just going to die anyway. You know, why are you treating that lady's osteoporosis? She's just going to die anyway. And I'm fairly sure that the response that someone would get if they did that would be pretty short and sharp. Whereas if I turn around and say, I'm going to treat osteoporosis, diabetes, and cancer simultaneously, I get people saying, "My God, you're playing God." You know, at which point I fall back on an old English saying, which is, "There's an ounce of queer as folk."
Do you think, like, in say 2100, the average person like the UK or the United States will live to be like 90 or 100 and not have any illnesses?
Well, you then start to. This is an interesting area because you start to get into prediction. I'm always very cautious about prediction because I have a mildly guilty hobby, which is I collect old visions of the future. You know, all those cities from the 60s, all those cities of brine nylon and Teflon that we should be living on the moon and aren't. Yeah. The ability of humans to forecast over a 30-year period is really poor. We don't know what our ability is we don't know what the future will look like, but we do know what our ability to foresee the future is, and we're terrible at it. Now, there's various bits and pieces where you might be able to refine those. All I can say is what's happening now, which is we know there are treatments that will improve, say, vaccination efficiency. We know we can repurpose drugs. We know that more drugs are coming down the pipeline. And we also know that without a lot more money put into the upper end of the pipeline, that progress is going to be slowed. But effects will occur. I think the question about size and scale and where will it go, it is, you know, you wouldn't ask if you imagine asking a guy in 1930 what the year 2000 will look like, my guess is as good as that guy's. And what we can say is that things are happening, they are interesting. What the long-term consequences will be, I don't know. The short-term consequences could be quite positive for public health. We could be looking at something along the lines of control of blood pressure, which really only started in a big way in the 80s. And the benefits to everybody have been big.
Thank you so much for joining us today. Just kind of two final questions before you get out here. Just one, where can people kind of find your research, get a hold of you, any information you want to share about yourself?
For a lot of stuff, particularly if anyone's listening in the US, your first port of call should be the American Federation for Aging Research website. It's got a huge amount of stuff. I have a web page at the University of Brighton. I'm not on Twitter because I pick my fights in person. So, and I'm not on Facebook. I very rarely post anything on Facebook because I believe the planet doesn't need to know what I had for breakfast. But you can email me at my university email if anybody is interested. A lot of my papers are in the public domain, but AFAR is where you should go. Or in the UK, if you want to have a look at the work of the Biotechnology Biological Sciences Research Council's funded a lot of this over the years, or the British Society for Research on Aging. They're good places.
Finally, leave us with a final thought related to this podcast or whatever is on your mind to wrap this up.
I wonder who's going to have the first large-scale patents on these indications, because the guys who do and the guys who have the productive capacity are going to make things like Ozempic look small time. That's the thought that what kind of worries me right now. Who's going to get there first?
My dear friends, that is it for this episode of El Podcast. Once again, if you're not yet subscribed, please subscribe on YouTube as well as Rumble. You can also find us on Spotify and Apple Podcasts or wherever you get your podcasts from. We thank you all from the bottom of our hearts for watching and listening, and we will see you on the next episode.